Thank you, Elsa. Thank you, Giselle. Thank you, Jean-Paul, for organizing ETRA, Bruno. This is such a nice community here, and it's great to come back every year. So I'm a consultant. I work on tire-to-tire recycling, mainly, with a focus on pyrolysis and recovered carbon black. I worked in the carbon black industry. And I'll tell you why the tire-to-tire recycling is so important for me. It was mentioned by Robert. It should be the ultimate goal. When you think of producing products, we need to think of engineering products so that they can be recycled easily. Now, the tires simply are the biggest rubber piece in the car. You have body sealing, you can rip the body sealing off when you recycle the car. There was a study on a Golf Mark II, so older Golf model, and there were 600 rubber parts in there. And most of them were between 2 grams and 10 grams. So you cannot recycle these things. And that is my motivation, my personal motivation, to go to actually work on tire-to-tire recycling, because the tires you can get out of the car, the body sealing you can get out, but you cannot really recycle from automotive vehicles, the smaller rubber parts. Of course, they're reduced with the electric vehicles. Second thing, for me, I don't think we have any technical challenges. I do disagree. I think we have all the technologies we need, and we need to implement and build and scale up and increase the amount of tires recycled by all processes. There are synergies between the processes. Of course, the process close to my heart is pyrolysis and recovered carbon black. I want to talk about progress, but I also want to talk about challenges. And the challenges, I want to challenge you. I want to bust some myths and actually, hopefully, make you, inspire you to think again about recovered carbon black and pyrolysis. And the first question I ask anybody I talk to about recovered carbon black and pyrolysis, for me, it's really the people who are the main opportunity, the main challenge as well. And there's 2 paradigms. And Ramon, I love your presentation, fantastic work, and you couldn't have done a better transition for me, because there is a paradigm change. It is needed, but it is also happening, and that is from economy to ecology. Now, admittedly, we are here at the European Tyre Recycling Association, but I invite all of you that do pyrolysis and maybe even the other processes not to consider yourself as a recycler. Who is in recycling? Raise your hand. Who is a recycler? I invite you not to be a recycler. Recycling, as Ramon explained, is you take something, you take maybe some garbage and you convert it in a process and you make something and you make some money. But the starting point is the garbage or the waste tire, end of life tire. I think the new paradigm, we are a production industry. Where are the tire makers? Michelin, Toyo, we had tire makers here. If they want to use our products, they need to be engineered. I will talk about engineering in my presentation. So we need to go backwards. We have, hopefully, soon a specification for recovered carbon black. We need to think, how can we get to that specification? And the starting point is the market, not the material. However, what is also, I think, a misconception, we are in the pyrolysis forum, but the pyrolysis, at how much percentage has the pyrolysis influence of recovered carbon black quality? I would say less than 10%. Because in my opinion, the process to produce recovered carbon black starts at the selection of the tires. That has maybe 50-60% influence on the quality of the recovered carbon black. Pyrolysis is just separating the materials and maybe hopefully drying the recovered carbon black. And then we need to post-process like Ramon showed. So I invite you to change the paradigm to become a production industry, no longer a recycling industry. But let's go with my presentation. Structure of my presentation, I will show you a little bit about recovered carbon black history and carbon black history, and we can compare the two. We'll talk about the scale-up, I will show some major EU players. I think Ramon's slide was even more, your slide was more complete than mine, because I only look at people who could supply recovered carbon black or close to supplying recovered carbon black. We talk a lot about specifications, because I think this year we will actually solve the challenge of recovered carbon black specifications, and I will explain you why. And I will give you an outlook. I have a tough message for the tire companies as well, but let's start. So I won't go through all of this. This is a very busy slide. On the left-hand side, you see the history of carbon black, and you can see in orange 1940 furnace process, soft blacks. So Jean-Paul, I don't know, your birth year, that was around the furnace process, more or less, isn't it? So, and the furnace process was optimized for 80 years now, for more than 80 years, to be efficient, to be cost efficient. But cost efficiency also means sustainability. And we can say now it is as sustainable as it gets. And we see big carbon black makers, starting with Birla Carbon and Circtec. Now Cabot has introduced a platform for sustainable carbon blacks, including recovered carbon black. They need something to get away from the furnace process carbon footprint, which I don't think can be further improved than it is now after those 80 years. When we look at recovered carbon black, really the first focus on what was called carbon black pyrolytic, CBP, back then, and there was a company also with that name, was in the 2000s. Important things, 2014, Bridgestone investment. What is new, what I found recently, 2016, the TSCA, the Toxic Substances Control Act, that's the American reach. And so there was actually an anonymous registration. I don't know what that company was. I think it was Delta Energy, but it is anonymous. 2017, ASTM 36 was created, and we get really the success story. For me, the news of last year, really Alpha Carbon, brilliant work with Circtec on the REACH registration. Now it's all easy. We have regulatories in the pocket, do we? No. Very well so. So I'm preparing for a consulting client a REACH inquiry dossier, which they need to be mapped to Circtec or Alpha Carbon based on the boundary conditions. It is so difficult to make a REACH inquiry dossier. The amount of data you need is just humongous. So there's still some work to do, but we are on the right track. That's the good news. That slide, that's the same chart I showed last year. And that is the scale up of the industry. There's one thing which I have changed, and actually this is from a report I'm doing with Notch Consulting, Prospects for Recovered Carbon Black. We think it's the best recovered carbon black or pyrolysis industry report. Really, we still think the volumes are about right. We're talking about a massive growth in Europe, massive growth in the chemical ports of Antwerp and Rotterdam. However, we did extensive industry interviews with all key players in the last couple of months. We think the industry is about half up to 1 year late, so that the big volume in Europe, what you can see over here, the light green part in 2025, that will only happen in 2025, not 2024. By the way, the cartoon art is artificial intelligence. I couldn't copy the Tim and Snowy, the Tintin and Milou, so I had to use artificial intelligence, which some people use also for tire pyrolysis. The pictures don't work well, but ChatGPT gives you surprisingly detailed information about tire pyrolysis. So in Europe, I see 24 companies, varying TRL, between 6 pilot and 9. Of course, there's more with the TRL below that, but generally these are not the companies I focus on, because again, I work on the sustainability paradigm, on the production, on the high quality recovered carbon black. And we can put names to them. So we got technology companies, companies that are just operating, they don't have their own technology, they're a licensee of somebody else's technology. You have companies that do both, for example, Black Bear Carbon. You have companies that do only refining, like Waverley Carbon in the UK. Now, that's the fillet piece of my presentation, the journey to specifications. In 21, I worked with Bridgestone, and there was a need for recovered carbon black specifications. There were none, so I created some, and I think it was a good starting point. One key for me was the consistency, and I went about and I defined a CPK, a process stability value, which is required from the RCB. That came from actual data of the ash variance of RCB. And I defined RCB1, state of art, RCB2, like a second category, RCB3 raw, which is only really for thermal use. And RCB0, that is a concept, and it hasn't been fully developed. Maybe it cannot be developed. That was the idea, to activate and post-treat recovered carbon black up to a hard black reinforcement in rubber, meaning to be on the same level as a 300 group carbon black. Then, of course, as all of you know, Michelin and rubber, the arch enemies of tire production, they work together on recovered carbon black. For me, this is like the most positive thing. And I tell my small startup clients in pyrolysis, look, if Michelin and Bridgestone, they can work together, everybody can. You can do also with your work with your peer companies. They're not competitors, they're collaborators. Key to that specification was feedstock. As I said, the feedstock maybe makes half or more of the quality of the recovered carbon black, also the quality of the oil. Engineers say garbage in, garbage out. If you don't control the feedstock, that is the first process step. It's not the pyrolysis. The first process is to select and cater and do a diet of tire mix that is consistent to the pyrolysis reactor. Dispersion was in there, post-treatment, and also a certificate of analysis specification. What was missing in that specification was rubber properties. Why? Because Bridgestone and Michelin, they have different ways of accessing rubber properties, and they wouldn't disclose to each other. Also, I will specify now in a couple of slides, there's a nice test by Continental. You all know Jorge Pineda and the Fourier transformation rheology. That is my go-to in rubber test. There's an exciting work item in D36, which is due for ballot only next year in December. But I will show you, I think this year we're ready to really nail the specification. I think we could even do it until the end of this year, not the end of next year. I think we have everything we need. We have all the tools in the toolbox to nail specifications. Let's look at furnace carbon black classification. So I won't go through, this is from the ASTM, you can read it. Terminology relating to carbon black, we have the same document relating to recovered carbon black. I highlight you some things and then I show you the pyrolysis process and where those things are relevant. We need an engineered material made on purpose, not a recycled material. Some tires in the pyrolysis, some black stuff comes out, that is not recovered carbon black. If you say recovered carbon black has poor performance, that is maybe the reason it is not recovered carbon black. Recovered carbon black has performance. And the problem is we're comparing apples and bananas. We're comparing poor recovered carbon black, which has been made, or we think is recovered carbon black, made on an economy paradigm with good carbon black or good recovered carbon black. So we're comparing apples and bananas. There's now a proliferation of sustainable carbon blacks. And Ramon mentioned sustainable carbon black, but sustainable carbon black is a category. Within sustainable carbon blacks, we can have circular carbon blacks from tire pyrolysis oil. We can have renewable carbon blacks from typically pine oil or any biological material. We can have, of course, methane pyrolysis carbon black, although natural gas is not really natural. Only when we use biogas and when we use green electricity, then this is a green product. And we have recovered carbon black. Now, the carbon black definition here we have on the left side. And recovered carbon black is failing. It's not a thermal decomposition of hydrocarbons. So it fails the definition of carbon black. Some companies, carbon black companies, now call it, Carbon calls it reclaimed carbon. They omit the black. I don't think we should discuss too much about the name and give new names, but we need to be precise on what it is. And of course, we know aggregates of a cuneiform morphology. That is not the case for recovered carbon black. Of course, it has the carbon black. Very often it looks like a sponge because we have the carbonaceous residues around the carbon black, which has holes where the gas has exited and evaporated from the solid fraction. So actually we have the inverse of a cuneiform. We have like a sponge form before the milling. When we mill, we can see a cuneiform as well. Uniformity of primary particles from the process, we don't get that only with pyrolysis. We need to mill because we have a particle size distribution of microns to millimeters of the raw recovered carbon black. That's the reason for milling. And the finer we mill, also, the better is the dispersion, and the better will be the in-river properties. As previous presentations have shown, no dispersion, recovered carbon black cannot do its work. So, what about the recovered carbon black classification? We have the standard terminology relating to recovered carbon black. So we have thermal decomposition, free of wire and fabric, okay, milled, okay, and it gives semi-reinforcing properties. Why semi-reinforcing? The one reason is carbonaceous residues, but let's keep in mind we're putting all types of carbon blacks. We're putting whole tires in and various mix of tires. So we get a mix of carbon blacks. We cannot expect any 300 type of carbon black performance if we input a mix of carbon blacks as a feedstock. Oh, how to go back? Here. Test methods. So there's the work item recovered carbon black classification, which has to rely only on ASTM test methods. That's the production process, and it's quite complex. It's a little bit more elaborate than what you've seen in the previous slide. Let's highlight very important places of the process. It's an engineered material, so we have to select the feedstock. That is super important. Via thermal decomposition from rubber goods, that is where we separate gas, oil, and raw recovered carbon black. The mass balance Raman showed is very simplified, like an academic mass balance. Maybe Life for Tire, Bogdan, you will confirm there is fractions, mass flows that are almost never mentioned, only by those that have industrial plants. You will get sludge from the distillation. You will get sludge from the cyclone to clean the gas. And you need to sell all those mass streams. Of the gas, if you want to use it for a burner, you need to get rid of the C5 and C6 because the burner, C5 and C6 will kill the burners. You cannot burn the gas if there's C5 and C6. Fortunately, C5 and C6 is a pure product that can be sold as well. But the mass balance typically shown for the pyrolysis is like a theoretical mass balance, and the true mass balance is much more complex. Free of wire and fabric, okay, we can do magnetic separation, milled, and the milling is doing the uniformity of aggregates. That is the composition of recovered carbon black, and it will continue. So we have carbon black, we have inorganic compounding ingredients, we have elemental carbon. And the first part is depending on the tires, on the feedstock, and the second part is depending on the pyrolysis process to evaporate the volatiles and hopefully not create a lot of coke or carbonaceous residues. Now let's look at, for each of those things, how can we measure? Carbonaceous residues we can measure with rubber performance, with the FT rheology. The volatile hydrocarbons, we have several tests. We have the new TGA, thermogravimetric analysis test, and we have the toluene transmittance. That is a well-known test, a quick test where you can see the performance. The ash content, again, we have two tests. We can use the carbon black method, 1506, which is ash content, or we can use the TGA. The type of the mixture of carbon blacks will determine the rubber performance, and so that we can measure with the FT rheology. There really is only one test missing, which is which could show us the dispersion, and that is the particle size measurement test. But we all know we are set for laser diffraction, 2 bars, dry, and Fraunhofer algorithm. So that is pretty much also in the toolbox. I believe we have all the tests we need to do the specification this year. The outlook. How can we accelerate? Well, the tire people told you was there. Tire industry has done some investment, but the tire industry could do much more. What is 3 million for a Michelin that has 20 billion revenue? That is not even peanuts. But what is 3 million for a tire pyrolysis company? How long do 3 million last? Maybe 1 year with a cash burn. When you do engineering, maybe not even 1 year. They don't have enough money. And that is a major slowdown of the industry. The tire industry also, and the carbon black industry, they should not only invest into the assets, into the plants, but into the companies themselves to keep them going, to get R&D going. Now we see carbon black industry engaging, and that is good because they've seen recovered carbon black as a competitor, as a lower ranked material that is still stealing them some markets on the lower side. Now that paradigm has changed as well. Ecosystem collaborations, Black Cycle, RCB Rubber, collaboration between Michelin and Bridgestone, Chem Cycle on the oil side. These ecosystems, they grow together. Once they're built, they need to be interconnecting. And I think the big companies, the big corporations, they need to be fair with the pyrolysis companies. They cannot cherry pick. An Orion engineered carbon cannot say our sustainable carbon is better than your recovered carbon black. We only take the oil from you. They need to know that if they want 1 ton oil carbon black feedstock, the pyrolysis company has to sell 4 tons of recovered carbon black for TPO, for the carbon black oil, quality oil. So recovered carbon black needs to be sold so that Orion engineered carbons can get oil for the sustainable carbon black. That's important. And it's only fair that they take in both materials because they're interconnected. Specifications, rubber testing, the D3670 group, very encouraging. There's all the carbon black makers, there's all the tire makers in there. I think it's a good work group. We talked about the work item about the RCB classification. Regulatory, we talked about as well. We got the REACH license for recovered carbon black, but it's still very difficult for each company to benefit of that. The REACH dossier is quite complex. And again, I invite you to reconsider what industry you are in. Are you in recycling or are you in a product making industry? And that's it. Little marketing on my side. I didn't do much marketing. I have a pricing brief updated for April 2023 with all carbon black prices, recovered carbon black prices. I can answer your question about the green up price for recovered carbon black. I can tell you recovered carbon black is more expensive than furnace carbon black because also the supply is much more scarce. We do the report, Paul Eiter and I, and I'm doing a webinar on April 11th and about RCB and rubber. I did some webinars, RCB in plastics and inks and coatings. Now finally, I also talk about RCB in tires. Thank you for your attention.
Thank you very much. We will allow just 2 questions for the moment, please.
Martin, I
Jean-Paul.
just have a question I think we have already discussed, but about the potential you mentioned, 335 kilotons per year in 2025.
That is the capacity installed. Probably you can take something off because
when you mention the capacity,
supply. That is supply capacity out of Europe. Yes.
Because if we consider the market of virgin carbon black, it's possible. But if we consider the quantity of ELTs produced in Europe, it will be very difficult because you will have the cement factories. We use a lot, 38% of the potential, it will be very difficult to have to get the raw material for producing this.
You mean to get the tires in, which is the reason the big installations, they are in the ports of Rotterdam and Antwerp, and they can consider getting ships, barges in of tires. Of course, then if you get the tires from very far away, you get an additional carbon footprint, and then the question is about the sustainability credentials. So, but that is actually one important strategic thing. Every company that is industrializing needs to secure the feedstock. And we say, yeah, we are exporting so much to India, 500,000 tons, and also the cement kilns, but everybody is making money, so changing the flow of the tires is not very easy. One more question, Danny.
Thank you, Martin, for a very interesting presentation. As you mentioned, we also see in our analysis that from feedstock to end product, that what goes in comes out. And so it really determines the quality and where you want to end in your end product. That's what should determine your feedstock. Can you enlighten a little bit more? Or maybe we get in too much now into the kitchen secrets, but can you enlighten a little bit more on the important parameters to what needs to be there to achieve a good quality recovered carbon black?
It's the so-called Starbucks strategy. Make the same low quality everywhere. Actually, the only thing we're looking for is consistency. It doesn't matter what you put in, but you want consistent properties. And the things you look is the chemical composition of the tires, specifically also the inorganic content, sometimes called ash content, but also the type of carbon blacks that are in the tire. We want all the four components to be consistent. And as for the tires, it's the type of carbon black and the rubber additives, inorganic rubber additives that end up in the RCP. And consistency is key. And then, of course, you can cater. You know, if you pyrolyze only truck tread, that would be fantastic. That would be almost no silica, only very high grades, N100 and 200 grades of carbon black. But that would almost be a shame to pyrolyze that. That should go into devulcanization because it's such a good material.
Okay, as we are short in time and we are getting a little late, thank you very much for a very nice presentation.